Hi, welcome to the lesson on geometric patterns. So, firstly, we want to take a look at geometric sequences. A geometric pattern is a sequence of numbers in which the ratio between the consecutive terms remains constant. If you've just come from watching the videos on arithmetic patterns, then you know what consecutive means one after the other. So, this is a pattern such as 2, 4, 8, 16, and so forth. Now, what is the common thing between these numbers? What is the common trend? If we try and subtract 4 and 2, we get 2, but 8 and 4, we get 4. So there's not a constant difference, but there is what we call a constant ratio. Now, this constant ratio is defined as such. The ratio is equal to term number 3 divided by term number 2, or term number 2 divided by term number 1. Either of these should give us the same thing. So if we say 4 divided by 2, we get 2. 8 divided by 4, we get 2. 16 divided by 8, we get 2. Therefore, the common ratio is 2 for this example. Now, just like the previous pattern, we also have what we call the general formula, which is Tn is equals to A r to the power of n minus 1, where A still represents the same thing. A is the first term of the pattern. R is now represented by the ratio. The equivalent of the arithmetic sequence would be D, the difference. So, everything else would be identical. Tn would represent the value at a given n number. So if we want to find term number 4 would be 16, where n is the position of that term value. The term value is the value at that position. Hopefully that makes sense. So yeah, we can go on indefinitely. That is just a geometric sequence. We just list the sequence of numbers going on and on and on. And also be aware that there are questions in which you are given the value of Tn and you are asked to find n. So in that case, such as this one, then let us try it. If we were to ask to find which term number in the pattern would have a value of 32. So we'd say 32 is equal to 2, which is the value of A, and R, which is 2 to the power of n minus 1. Then we can divide both sides by 2 and solve it algebraically. 16 is equal to 2 to the power of n minus 1. Then this will be 2 to the power of 4 and 2 to the power of n minus 1. Therefore, you can say n is equals to 5. And we can see that term number 5 is the next one. 16 multiplied by 2 does indeed give us 32. So be versatile with the formula. You should be able to solve for any variable. And since you have the knowledge of logarithms, you should be able to solve for complicated versions of these patterns. But don't expect to get ridiculous numbers from the NPT, since they counter for the fact that you do not have your calculators. So moving on to the geometric series, again, same nature, except the divider between the numbers now is an addition sign. So we have 2 times 2 to give us 4 plus 8 plus 16 and so forth. Now the sum of formula, or the series formula, will be A r to the power of n minus 1 over r minus 1, or you can have it as A 1 minus r to the power of n over 1 minus r. It just depends on which formula you prefer to work with. Some prefer to work with this one when r is a value such as a fraction, but some others prefer to work with this one when r is greater than 1. But you still get the same answers out of both of them. And there isn't anything too complicated. You can watch the arithmetic video where I talk about the series and the nature of the following formula, where Tn is equal to Sn minus Sn minus 1. So you should be able to implement this formula within this type of patterns as well. Then lastly, we want to talk about convergent series. So a convergent series is one that can be calculated, is a series in which we can calculate the infinity thereof. So in these type of geometric series, the ones with r greater than 1 or r smaller than -1, we have that the pattern grows indefinitely or unstoppably. It just keeps on getting bigger and bigger and bigger. But with the convergent series, r is limited to being -1, between -1 and 1. Therefore, any pattern that has this condition, such as 8, 4, 2, 1, a half, going on and on. Here, term number 2 divided by term number 1 doesn't give us 2, it gives us a half. And a half meets this criteria over here. Therefore, it is possible to calculate the sum to infinity of this formula using of this pattern using this formula, where a is the value of the first term and r is the ratio, and the ratio needs to satisfy this condition. It needs to be a fraction between -1 and 1. So what do we mean by calculate infinity? It means that we can basically, what's going to happen is that these numbers are going to continue to get smaller and smaller and smaller. The following one is going to be 1 over 4, the next one is going to be 1 over 8, and so on, going on and on and on. And the numbers are going to become so insignificantly small that it doesn't make a difference when we add it to the number that we currently have. Therefore, we can say we are able to quantify the sum to infinity for this pattern. So we're not limited to just finding this, the sum of the first 1,000 or 2,000 or 3,000. We can actually get the sum to infinity for these types of patterns, and it will always be a whole number. So that is that, and yeah, that is geometric patterns and all you need to know.